Hello everyone, welcome back to my channel. In this video, we are going to be talking about MATLAB from a very basic perspective. Whether you are completely new to MATLAB or you have some knowledge of it, or you are someone who learned about it a while back and have completely forgotten it, I think this is the video that could help you out. I'm going to be talking about it from a very fundamental perspective and hopefully give you some confidence about if you're thinking about pursuing computational sciences. This is not a video where I would be focusing on one particular subject. This is quite a general video, and the idea is to give you a very good and fundamental grasp on the programming language. This video is going to be quite long since it was supposed to be a tutorial session for a class that I am a TA for, but for the sake of ease, I have divided this video into multiple chapters that you can access. You can pick which chapter you want to access first, but I would suggest you to watch it sequentially if you are someone who have never done it before. It would be much better if you have your own laptop and you have installed MATLAB so that you can practice alongside while you learn. The video would be a combination of PowerPoint slides and demonstration. So just be a little bit patient if you don't get into the software part straight away, because the way in which I like to teach is first to give a little bit of theoretical overview before delving into the real action. In case of any questions, you can either email me or you can drop your questions in the comments. Both of them should be a sure shot way to get an answer, but I hope you would have some patience because sometimes I get a bit overwhelmed by all the response. But thank you so much for staying here, and I hope you would enjoy the content. So without wasting any further time, let's get started. So we would first begin with the very fundamental part of MATLAB, that is how we can define a variable. So for example, if you are asked to solve a problem, you are usually told that so for example, if you are solving a problem in a rectangular domain, you might be asked or you might be needing to specify what is the size of that domain, what is the length, what is the height. And similarly, when we have the problems of scientific interest, we have some fields. So for example, we could have a velocity field, which could be a two-dimensional field or a three-dimensional field. We could have a scalar field, for example, temperature or a pressure. So first, we would look at the way in which different kind of variables can be defined in MATLAB. So one very simple example is to define a scalar. So a scalar in the context of MATLAB, as to what I am talking about, is simply a number that you can define. So this is simply a screenshot that I've taken from MATLAB, and here I have written, you can ignore these greater than sign. This is inherent in MATLAB. Whenever we type something, these greater than sign comes in. So what I want you to focus is on what I've written here. It's called num_a equals to 15 followed by a semicolon. So here, this is the basic syntax of defining a number. So what I am defining here is the name of the variable, which is called as num_a. So this num_a is the name of the variable. And it is important to note that you cannot use any space in the name or any kind of special character like hash, @ or something like that. So no fancy names are allowed. You can't use your PUBG username here. You have to stick to like a very simplistic name. I think there is no restriction of how big the name can be. I mean, I've tried very long names. I don't know. There might be some restriction, but I'm not familiar with that. So you can define number_a_final, something like that. OK. And on the other side of equal to, we have the value of the variable. So we are assigning a value of 15 to this variable that is called as num_a. So if this value is this value could be integral value. So for example, here we are defining it as an integer. It could be a decimal based value, which could be, for example, this 5.98. It could be negative value as well. And in the computational sense, this is called as a floating point. So you might see something called as float coming around when you would be looking around in MATLAB. And this could also, I mean, using this equal to operator, you can also define strings. string is simply some sort of character. So if I want to define some string, for example, this when I want to write hello, in MATLAB we have to use these single inverted commas to prescribe that this is a string. Otherwise MATLAB would not understand that this is a string. And once again, string is nothing but a set of characters. The reason why I have semicolon here is that it would suppress the output, and I would talk about this in a little while when we would be talking about the demonstration part. So if I remove the semicolon, you would actually see the output of this particular line. It does not make the code right or wrong. There is nothing like that. There is no error if I don't use this semicolon. It is just that for the sake of convenience, whenever we write codes, we don't want to see a lot of output at the same time. So that is why we are going to use this semicolon quite a while when we would be writing the code. And if I run this particular line, that is num underscore a equals to 15. And if I ask MATLAB, so you can just ignore this line as to who is or whose num underscore a. So it is basically meaning to ask MATLAB to tell you about the properties of this variable that is called as num underscore a. So MATLAB would tell you that it is a variable that has a size of 1 by 1. So there's a very interesting thing about MATLAB that it likes to deal in matrices. So I think the word MATLAB is basically combining the word matrix and laboratory. So MATLAB is basically representative of a lot of matrices being talking to each other. So if you look at this number, that is any number, which is simply an integer or a floating point, you can think of it as a matrix that has a size of 1 by 1. So when you would ask MATLAB as to what is the properties of an integer that you are storing it in, so that would come out as 1 by 1. So I hope that this would be at least comfortable with you all. We would actually look into it when we would be talking about the demonstration part in a little while. The second thing that you would need to initialize or you would need to define is definitely matrix. So for example, you could be coming across situations where you have a two-dimensional system where you would definitely need a matrix, or even you could have a one-dimensional system in which you would need what is called as a vector. So there are many different ways in which matrices can be defined in MATLAB. So I would first show you some of the ways, and then we would head to the software very shortly and show you how it is done. So just like how we were defining the scalars, the matrix assignment or the matrix definition is very similar. So we write the name of the variable here, that is num underscore b. We put an equal to sign to say that we are going to assign something to this variable, that is num underscore b. And then I write something very complicated looking. It says that once 15 comma 11. So let's try to understand what that is doing. So this particular command, once, it defines a matrix that has all elements being equal to 1. So the name itself suggests that, right? So when we write once, it means that we are defining a matrix which has all elements equal to unity. We can do the same thing if we want a matrix that has all elements equal to 0 by using zeros instead of ones. And this is something that is very typical with computational initialization. A lot of times we have to initialize the variables and we don't really want to initialize it with some very meaningful number. We either use 0 or 1 for a random initialization. Now these two numbers that I have in brackets here is defining the size of that matrix. So in MATLAB, usually always the first number corresponds to the row as to how many different rows are there, and the second number corresponds to column. So in this num underscore b is going to define a matrix which has 15 rows and 11 columns, and all of these columns or rows or all the different elements would have a value of 1. So this is one of the like automated kind of definition as to how you can define a matrix, especially if the matrix are very large, then this method works very well. But sometimes if the matrix are small, or if you want to specify the exact elements, then that is also simply very simply possible. You simply write, for example, I write num underscore c equal to, then I start with a large bracket. So notice that here I'm using large bracket, but in the previous case I was using small brackets. So this is something that you would gradually get comfortable with. MATLAB usually would show you errors if you would try to use large brackets here or small brackets in this kind of a manner. So if I want to describe a matrix that has, in this case, two row, so there is first row which has 3, 4, 1 and 3 columns. That is, if you can see here, this is first column, this is second column, this is third column. So in this case, the large brackets are used when we want to define any kind of multi-dimensional variables, especially 2D variables, because it's hard to visualize a 3D variable if you want to initialize it using this. And the way in which we enter is we first write down all the elements in the first row, we hit enter, and then we continue talking, we continue putting in the elements in the next row. And if there are even further row, you don't close this bracket, you keep hitting enter and keep defining the next set of rows. Okay. Are there any questions until this point?
Excuse me, sir.
Yeah.
So can you please explain the use of this square bracket and round bracket once more?
Okay. So
where we use square brackets and where all we use round brackets?
Yeah, this is actually something that is this is a part of what is called as a syntax of this programming platform. So this is the way in which MATLAB understands. So let me put it this way. So if you put small brackets here, then MATLAB would understand that you are trying to initialize a matrix of size 15 by 11, where all the elements are 1. If you put large brackets or medium brackets, then MATLAB wouldn't understand that. So especially the large brackets, it wouldn't understand because that's the way it has been programmed on the backend side. So this is something that probably just have to remember as you would be doing the programming. Of course, when you would run this code with large brackets here, then it would show up error. It would show that, OK, I don't understand this kind of parenthesis. So you might have to do something. So for example, when you be doing C or C++ programming, they typically use the large brackets. People who have done C, they would know that for all the initialization or calling of the different variables, the syntax of C is such that it uses large brackets almost everywhere. But in MATLAB, you use all the different kind of brackets, so things get a little bit messy. Even nowadays, I do mistakes, but it is very easily identifiable since MATLAB tells you the error that, OK, this bracket is something that I'm not able to understand or process. So as of now, you don't have to worry. When you would start to code things, you would gradually get a hand on whether to write small bracket or large bracket. OK. All right. So let's proceed further. So this was the part where we are initializing the different kind of variables. So now let us understand something that is called as an indexing. And this slide might be a little bit different. If you don't understand it, that is fine. But let me just try to give you an idea. So for example, if we have these 5 points, you can just think of these 5 points. And when you would be taught CFD, then there would be something called as counting of these points. So this counting is sometimes called as an indexing when we are doing it in arbitrary form. So for example, if I say that the number of this particular point is I, then I hope you would agree that the count of this point would be I plus 1 and the count of this particular point would be I minus 1. So you can think of I as, in this case, I could be 3, then this is number 4 and this is number 2. So people in CFD or computational sciences, they typically use I, J, K kind of notation. So that's what I'm using here. So if you do the counting here, it would be 1, 1, 2, 3, 4, 5. And fortunately, that is how also MATLAB understands it. So if you would try to define a variable here, so for example, if I want to define a temperature here, I can simply use something like T small bracket 1, T small bracket 2, T small bracket 3, and so on. In a lot of different languages, this counting might start from 0. So for example, people who use C, they would know that the first point or first element, they would be using T of 0 to call that number. So this is something that is different if you are migrating from a different platform. So this is something you might want to keep in mind as to how the MATLAB is working. So So for example, in the previous slides, we have initialized something, but now let us say we want to call something, that is we want to inquire as to what is the temperature at point number 3. Then we would simply write this expression, that is T small brackets 3. So if you're not completely understanding what I'm talking about, that is fine. So let me jump to MATLAB and we'll talk a little bit with software in mind. OK. So this is the basic interface of MATLAB. When you would open it first time, you might see something different. So don't worry about that. I'll gradually explain what is going on. OK. So on the top, you have this ribbon kind of thing where there are home, plots and apps. So usually most of the time you would be sticking into the home section. And this is where you would be most of the time. OK. Just below that, there is something like a file explorer kind of situation where there's a path of where you currently are. So this is important. So this is probably where this is the location where you would be working. So this is like a working directory in this is what it is called. So this entire thing is the working directory, or I am inside this folder, and all the contents of this folder are displayed here. So this says that this is what is called as a current folder. On the right hand side, there is something called as a workspace. So most of you, if you would be opening MATLAB for the first time, this workspace would actually be empty. So it would actually look something like this. So workspace is where all your data would be stored. You can think of this as a storage part of MATLAB. So anything that you would define here would be stored in the workspace. And in the center, this large part here is called as a command window. So command window uh, is your first entry point into MATLAB. So if you want to try anything, if you want to write anything, if you want to see what a command does, you can simply write it down here. So this is like a temporary coding that you can do later on. So for example, we had written that num underscore a equals to 15. So now if I hit enter, you would see that it shows num underscore a equals to 15. That is, it shows me the output. And in the workspace, there is a variable called as num a with a value of 15. If I write the same statement, that is num underscore a equals to 15. And now if I use semicolon, or let me write it to 25. So I'm just writing the same name, that is num underscore a, and I'm defining it to be 25 and hitting enter. So now you see that once I had used the semicolon, then I would not see this kind of output. And this is the output that I was previously talking about. And now since I had used the value of 25, so it had overwritten the previous value, right? Simple enough. So let me show you some examples of initializing that we were previously looking at. So forget the first 4 lines. So let us start from here. So I hope you guys would agree that num underscore a equal to 15 would give me a variable called as num underscore a. And since I had not used a semicolon here, then the output would be displayed in the command window. So this particular new section that I have opened, so this is the file that I opened here. So this file is called as some name .m. So .m is the MATLAB file. .m stands for a MATLAB code file, and this is what is called as a MATLAB code. So when we double click this, this opens what is called as an editor. So editor is where you can write the file, and then these files would be saved for your future use. OK. Then in the next line, I had written num underscore a equals to 20 with a semicolon. So I hope you would agree that this part is also fine. And then if I simply write num underscore a, that is, you can either write it directly in the command window, and then it would display whatever it has stored. If I write num underscore b, and if I hit enter now, you would see that it would try to first look into the workspace, and then it would say that I don't really understand what this variable is. Okay, so it first looks up whether is it any inbuilt function in MATLAB, or if it's not a function, whether it's a variable. And if it's neither of them, then it says that I don't really recognize this command. And if we want to clear some variable from the workspace, we can either right click here, click on delete, or we can write a command which says clear followed by the name of the variable. So I can just select this line, right click on it, and use this first statement which says that evaluate selection in the command window. That is, evaluate this particular line that I have selected in the command window. And as soon as I hit uh, or as soon as I click on it, you can see that this workspace is now the variable has now been removed from that workspace. So I hope that would be fine. Let me know if there are any questions before we proceed further. So the next part is about how to initialize a vector. So there are different ways in which you can define a vector. So the first way I have used is I've said that vector underscore a equals to 1 ratio 5. So let's see what that command does. So I selected it, right click on it and use the first one, that is evaluate selection. So when I use that, that is vec underscore a equals to 1 ratio 5, it says that it defines a vector which has 5 elements, that is 1, 2, 3, 4, 5. So what is essentially happening is that this first number over here, that is 1, it is the first element, and this number 5 is the last element. And when we specify a ratio, it means that the spacing between them is 1. I can do the same thing with different numbers. So for example, 3 to 8. Then the first element would be 3, the last element would be 8, and the spacing would be 1. So this is sometimes useful when you want to just quickly define a vector, but a lot of times you don't have to. There might be the case when the spacing between the two elements doesn't has to be 1. So if you want to use a different spacing, we have to use something like this. So in this case, if you carefully observe, I have added one extra ratio sign and then followed by 0.5. So if I right click and evaluate this line, so it says that the first element is 1, the last element is 5, but there's a spacing of 0.5. So the default spacing in MATLAB comes as 1, but if you want to modify the spacing, you can use this particular syntax. So in this case, as you can observe in the output, the difference between any two adjacent elements is 0.5. So these are the two very standard ways in which you can define a vector, but there are a couple of little bit fancy ways. So a lot of times you might be using or you might be needing to initialize a vector where you are given the first element and the last element, and you have to do a what is called as linearly spaced vector. So there's a command called as linspace, which allows you to, so as the description suggests, it allows you to generate n number of points that are linearly spaced between x1 and x2. So if I run this particular line over here, so if I just select this line, right click and evaluate selection, you would see that the first element is 4, which is fine. The last element is 50, which is fine. And the total number of elements that we want is 5. And both, I mean, all of these elements, all of these 5 elements, they would be linearly uh, distributed between the first and the last line. So that is, the difference between the first and the second element would be the same as the difference between the second and the third element. Charanpreet is asking, is the usage of semicolon only limited to not displaying the result in the command window? Exactly. So if I were using, so let me just run the same statement with semicolon here. And if I run the same statement, the statement would be executed and you would not see the output here. That is the only utility of semicolon when it is used in the end of this line or end of any line. OK. Similar to the linear space, there is something called as a log space, although this is something that is hardly used anytime. So log space, it creates logarithmically spaced vector. And the description says that if you write something like log space of x1, x2, n, then it would generate a vector that has n points, which are logarithmically scaled, but it is a little bit harder to understand since they are usually in the 10 raised to power of x1. So if I write something like this, which says vec underscore d equals to log space 1, 3, 5. So I'm asking to generate 5 points that are between 10 raised to power 1, which is 10, and 10 raised to power 3, which is 1000. So if I execute this, you would see that first of all it displayed it into the scientific fashion, which is already difficult to understand. So what it has done is, so I can also look at this vec underscore d in the workspace if I don't want to uh, understand this scientific notation, which I'm not usually comfortable with. So if I double click on vec underscore d, it would show you that the first element is 10, the last element is 5000, and the second, third, and fourth elements are such that these are logarithmically arranged, even though it is a little bit harder to visualize directly, but you need to trust MATLAB on this. Okay. So just like we have the clear command for clearing or getting rid of workspace for one particular variable, you can also use clear all command. And if you would execute this command, this would allow you to get rid of all the different variables all at once. So if I evaluate selection, you would see that the workspace is now completely empty. So finally, I have these other set of different commands as well, which are for matrix initialization. So I think I would probably skip out these commands. These are very similar to what I had described in the PowerPoint slides. And what I can probably do is I will upload this code so that you guys can see what these different commands are doing. Is that fine? So, okay, so now let me come into the programming bit as to a lot. There would be a different kind of situations that you would be needing to program to getting the like desired code. So a lot of times in computational setups, there is something called as nesting, or there is something called as repetitions. That is, you would be needing to do a same thing over and over again. So for example, if there are these 5 points, maybe you need to solve a particular equation on each of these points. The equation remains the same, but the points are changing every time. So for example, you are solving equation number, let's say equation A on point number 1, then point number 2, then point number 3, and so on. So this process, or the way to describe this process to any software, is called as a nesting, or in more simpler words, it is a repetitive process. So one of the ways in which, this is not the only way, you can be creative and do other things, but one of the very common ways in which this is done in many programming platform is using what is called as a for statement. So this is a very simple syntax of for statement, which says that for I equals to something something, and I would describe what is going on. So it says that for I equals to, here I represents an index that changes its value during the nesting process. So if I take the previous example, that if I want to solve equation A on 5 different points, then this I would take the value of 1 till 5. So this is a very simple example of how this for statement can be used. So in the statement, we define what is going to be the first value of I. So in our example, the first value of I could be 1 and the last value of I could be 5. And again, usually we use this ratio sign to determine the spacing. If we don't determine any spacing, the default spacing would be taken as 1. That is, I would vary from 1, 2, 3, 4, 5. Okay, I have represented it here, that this colon sign or the ratio sign, it represents the spacing. The default spacing is 1, and you can also determine any spacing dependent on your problem statement. And an important thing to note here is that anything that starts with a percentage sign is a comment. So comment is something that a language will not process, or language will not compile, or it would not produce results if something is a comment. So if I go back to my code here, you can see that this particular part, for example, so this is something that is called as a comment. It is useful for your understanding as to what you have done, but MATLAB would simply skip that part. OK, so it is very useful when you write the code, because if you're writing, let's say, a big code, and you would come back to that code after 1 year, 2 years, you might have forgotten what you have done there. So typically, I tend to write a lot of comments whenever I am coding. It's a very good practice as well. Okay, so this is a for statement, which is very useful if you want to do a repetitive process over and over again. So the process remains the same. So the content of this for statement, so whatever would come after this line, so whatever would be in this between these for and end statement, they would remain the same, but this index would be changing. So like I have given the example, the equation A would remain the same. The point on which equation A would be being solved, that point would be changing in every repetition. The second part or the second statement, which is typically used when we want to prescribe some conditions in computational fluid dynamics, is called as a while statement. I mean, this is again a simple representation. You can use other statements as well. There's nothing like you have to use only while statement. There are probably tons of different ways in which you can do the same thing, which can be done using a while statement. So in computational sciences, generally we solve the equations multiple times until some kind of conditions are met. So for example, until the equations are solved to some precision. So while statement is used something like this. So we say that while we prescribe a condition, and this there says that the condition is, just for the sake of your understanding, that the numerical error is greater than some error threshold. So these are notice that these are comments. So this is not the way in which we would actually write the while statement, but this is only for your representation and understanding. So we say that while then we prescribe a condition. The condition in CFD is usually of this particular form, that we say that we want to solve the equations until the numerical error is very small. And then MATLAB comes to this and it looks at the condition. It understands the condition mathematically and sees if the condition is true, that if the numerical error would be greater than some error threshold, then only it would execute that loop. If the condition is false, then the code would simply be skipped to this end statement or whatever is after the end statement. So uh, you can try to play around with this while statement. It is very easy. You can define some variables. You can ask MATLAB to do a certain thing. You can prescribe certain condition and see whether the loop is executed or whether the loop is skipped. So I'm not entirely sure whether you completely understand this if you haven't used any kind of programming platform, but this is something that you might be needing later on. So I'm just trying to give you some idea of the different tasks that are typically encountered in CFD. So for and while, these two statements are typically sufficient for a lot of different kind of problems. But if you want to write codes, there are something called as an auxiliary command or some helpful commands, which are a good coding practice according to me. So we had already looked at this clear all command or the clear command, which clears all the variables that are stored in the MATLAB workspace. So for example, if we uh, wanted to get rid of some variable, we just write clear followed by the name of that variable. But a lot of times we want to start off our code with clearing all the variables. So the typical practice that I usually follow is that I want to start off with a fresh code. So what I do there is I clear all the variables at first and then I write my code. A very good practice is also to use what is called as a close all, which actually closes all the figure windows. So it might happen that you are doing your coding and you are generating the plot, and then you want to run a different code which might interfere with the existing plot. So a good practice, or you can also think of this as a command which simply closes all the existing figures. So sometimes it happens that you don't want to overwrite any existing figures, then you can use this particular command. And my favorite command is called as CLC. That is, it clears the command window. So every time you would write a code, you would run a code, there might be some outputs being generated in the command window. So I don't like that. I usually like to keep the command window very minimal so that there are quantities that I want to display or minimal quantities being displayed on the command window. So every time I run the code, I start off with a clear command window so that I know that my code is not generating or displaying anything something that I don't want it to display. There are some other commands in MATLAB which is called as print or display, or in the short it's called as disp, that you can add to your code if you want to print something or display something in the command window. And this is an alternative if you want to get rid of this semicolon sign. So sometimes we deliberately want to print something to debug the code or to want to understand whether there is something going wrong in the code. So this is something that you can use. So I won't be probably giving you demonstration of the for and the while statement because a lot of you probably won't completely understand. But just to summarize, for is a statement that is used to do the repetitive processes, and while is the statement that is used to do a conditional process if you want to impose any conditions in the code. And these commands that I had displayed over here, these are not the mandatory commands. It is just a helpful command, and I typically recommend it for a good coding practice. The final part that I want to discuss with you guys is what is called as a plotting. And you would be doing that a lot in this particular course. That is, you want to visualize your data, right? Whatever calculations you are doing, you want to see what is the variation of a particular field. So one of the very simple way is to plot a line. So the first thing is this is something that this is not a mandatory thing to do. This is something I recommend. First, you start off with opening a new figure. So every time I want to create something or I want to plot something, I open a new figure window. It ensures me that I'm not overwriting any existing figure window. OK. And this is something that you might figure out along the way. So this is a good coding practice that you start off. If you want to draw something different, then you open a new figure window, and then you can start off with a very basic XY plot. So you want to plot something on X-axis, you want to plot something else on the Y-axis. You simply write plot followed by small brackets X, Y. This is the very simple thing, and it would give you whatever plot you are asking for. If you want to make it more fancy, you can add a lot of different arguments. You can even read about this plot command in MATLAB. And so for example, I can make it very fancy if I add something like this. Again, I'm plotting X and Y, but I have added a lot of different inputs. So if I first try to explain you what this line does, this is this saying that I want to create a dashed line. So I don't want to create a solid line. I don't want to create just points. I want the points, data points, to be connected by a dashed line, and the color of that dashed line should be G, which stands for green. And this S represents that all the data points should be like a square marker. So if I can try to show you or just write here. So it would be like a dashed line. So ignore that the line is red here, which is the only color in PowerPoint. And the symbols of the data point, they would be like squares. So you would see a line that would be something like that. And then there are other commands here that the line width is 2. So this indicates that this line, this dashed line that would be created, that would have a width of 2 pixels. So this is the unit of plot arguments that are used in MATLAB. And then there are 3 other lines which says marker size, marker edge color, marker face color. So again, the name itself, I hope you would be familiar. Marker size means whether the marker should be like this, or whether it should be like this, or whether it should be like very small one. So this represents you that the marker would be of 10 pixel, the edge color of the marker. So this outside color of the marker, whether that is, so B represents blue, and marker face color, that is this inside bit of the marker, whether that is of different colors. So I mean, this is a lot of fancy things that you can do with the plot. But if you simply want to create some very simple plot, you can just stick to plot X, Y. But a lot of times you might need to create 2-3 different lines in a plot. Then you might want to add something different so that you can identify different kind of lines. So for example, in one particular XY plot, you may need to plot something and then you might want to overlap something else. So if you use the same color, then it might become confusing. So there's a question about what is special about command window. Is it just a local window to have a glimpse of our output or for a given part of program instead of running the whole program? Yeah, that's a good one. Command window is like a lot of things actually. I was thinking about how to describe the command window and I don't really understand even now. So the name suggests that it's a window that can be used to run the commands. It's a window that is also like a calculator. So if I write quickly 23 into 3, hit enter, it would give me the answer. So a lot of things can be done in command window. So usually it is to test the different commands. It is not ideal to write your entire code in the command window because anything that you would be writing here, it's not really being saved. You can use the arrow keys to see whatever I have written in the command window, but a lot of times this could be just removed. So if you want to write your code permanently, or if you want to save the code, use the editor. If you want to check something while writing your code, this is where the command window comes in. And like you said, command window will always give you the glimpse of your output if you have. So for example, if I haven't used semicolon somewhere, then the output would be displayed in command window. And a lot of times we want to see the output, the numerical output or the textual output of our codes. So that is where the command window comes in. Actual way to learn any programming language is to actually do it yourself. I can always try to help you out, but unless, I mean, this is probably a very classic saying that unless you would be facing the bugs or problem in your code, you would not actually understand or learn how to write the code. So this is something that you would also feel across your assignment, that you would think that this line would work and then you would see that this line is not working, and then you would try to find out why it is not working. And during that process, you would understand a lot about how the software works and how it thinks. OK. The last slide for today is about plotting a 2D field. So plotting a line is fine, but a lot of times we want to see a distribution. So this is something that is usually obtained using what is called as a contour distribution. So in MATLAB, first we need to define a set of gridded coordinates. So think of it this way. So if let's say if I have an x and y axis, so usually I have some number of points, right? So let's say if I have these 3 points here on both x and y axis, and corresponding to these, I hope you can understand that I can create a grid of points here. So there could be 1 point here, 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 and so on. So there would be like a 9 different points. Forgive me for my drawing. I'm not able to draw using the the trackpad here. But if I have, let's say, 3 points which have 3 different x coordinate and 3 different points that have 3 different y coordinates. So using that, there's a possibility of getting 9 different data points or 9 different points. And that is first basic requirement of creating any kind of 2D data. So whenever we say that, let's say I have a velocity field in 2 dimension, which is usually given as u of x comma y. So first we need to find out all these x comma y. So that particular task is done using mesh grid, and then the contour f command. So there is this contour followed by this f. F represents the filled part. Contour f commands, it shows you the contour. So let me try to demonstrate this, because I know that this might be a little bit confusing if you just understand this. So let's go back to MATLAB, and there is another script that I have written here which is called as contour visualization. So this is only for contour. So the first thing when I want to do anything plot related is to use close all. So close all would close all the existing figure. So if I right click, do the close all, so I can be assured that all the figures have been closed. And usually I also do what is called as CLC, my favorite command, just to get rid of everything on the command window, and also to use clear so that the workspace is neat and empty. So let's say I want to create an X vector starting from 0 and ending at 5, such that the spacing between any two elements is constant at 0.01. So the first element is 0, the last element is 1, and the spacing is 0.01. So I hope you would remember I can use my standard definition of using the ratio sign or the colon sign. So in this manner, I can describe a vector that is called as x. So you can see here in the workspace that the size of the x vector is 1 times 501. That is, there is one row and 501 elements. So if I double click here, you can see that the first element is 0, the spacing is 0.01, and the last number over here is 5. Yeah, so if you guys have MATLAB installed, you're more than welcome to run along with me. You can try to use the same commands. You don't have to write the entire comments. You just write these commands and see what that would be doing. So in the meantime, I would just describe what I'm doing, and then we can I'll probably give some time, and then you guys can try to see whether that command works or not. So in this particular line, I want to specify that the first element is 0, the last element is 1, and there should be 35 different elements between 0 and 1 which are linearly spaced. So if I right click here and if I look at the output, which is the y, so you can see that the first element is 0, the last element is 1, and the total number of elements are 35, which you can see from this number here, and all of these elements have a linear spacing, that is equal spacing between any two different elements. So when we want to visualize any two-dimensional field, the first thing that we need to do is to create a grid. So we need to create a kind of grid of coordinates, and that can be done using this mesh grid command. So if you look at this here, our x is a vector which has 501 elements. Y is another vector which has 335 elements. So when we want to create a 2D data set, it is important that we have so like how I was explaining, if I want to visualize what is u of x comma y, it is important that we have x and y at each of those points, and that is what this command does. So if I execute this particular command, so it would create, so I have right here x underscore g and y underscore g, where g just represent that it is of a grid representation. Then you can see that xg and yg are actually a two-dimensional matrix. So xg has a size of 35 by 501, where 35 is coming from the size of y and 501 is coming from the size of x. So x and y were vectors, which are good, which are fine. But when we want to visualize a two-dimensional data, then we need that we need to go from this one-dimensional space to a two-dimensional space. So that conversion is done using the mesh grid command. So for the demonstration,
Sir,
yeah,
sir, so X becomes the number of rows and Y becomes the number of columns of my 2D matrix. Is that
exactly.
what we're doing? Yes,
Yeah,
sir. Okay.
exactly. Very, very good
Yes.
thing that you pointed out here. So the way in which MATLAB works is this, as you can see from the size here, that's one of the reason why I have chosen them to be of different size, that whatever you have in vertical direction, at least in your Cartesian mind, whatever is in y direction, that actually becomes the number of rows, or that is indicative of how many rows are going to be there. And whatever is there in the x direction, that becomes the number of columns. So MATLAB always works in row times column kind of format. So this is where you might have to be a little bit careful when you would be manipulating things in 2D, because in 1D everything is fine. You have only one variable to play with. But when you go to 2D, there might be some mismatch, because when we think of things in Cartesian system, they are not exactly the same as in MATLAB system. And this is something that you would figure out when you would be doing 2D assignments. You don't have to worry about them as of now, but just remember that if you use mesh grid in this manner, then the first row or the first argument is an indication of the total number of rows which is coming from your y direction. Okay, so here what I have done is I have just created a function that is called as I'm naming that as z, which is nothing but x square plus y square. So I'm calculating the value of z from the values of x underscore g and y underscore g. So at every point I am taking the local value of x comma y. I'm taking the coordinate x comma y and doing simply x square plus y square. So this is only for the visualization part. And now let me just quickly show you how that is done. So a good practice is always to start off by defining the figure. So I write here figure, and then in the small bracket I write 1. So this is basically the name of the figure. So figure, if I right click on this line and evaluate it, you can see that a figure is generated and the name of this figure is figure 1. So it is easier for me to understand what is being plotted into this. So what I would do is then I would write the contour statement, that is this contour f, and there are these arguments that actually goes in here. So let's understand what is going on. So the first two arguments are simply x comma y. The third argument is z. So you can think of a two-dimensional plot as something which is on the x and y axis. You simply have the x and y coordinate, and the distribution that you want to use is the third argument. So I want to see how the z look likes. Then there is something that I've written as 8. So 8 is what is called as the number of contour levels, and I would show you what that means. And then I have write edge color none. So for now you can just ignore these arguments, just ignore that I have written these arguments, and let me just run this particular line. So if I run this particular line, okay, I haven't specified Z. So this is an example when the MATLAB would show you some error. So in this particular line, it shows that it does not recognize the Z variable. And you can also see from the workspace that there is no Z here. So I need to run this line first. And then there is a Z here. And then I can use this contour F line. So if I go to my plot, you can see that this is the plot that MATLAB has generated. And now if you simply count the number of different colors that are there, so 1, 2, 3, 4, 5, 6, 7, 8. And I think this is extra 1. So this 8 represents the different kind of colors that the MATLAB would be using for the demonstration of this particular contour. And this line that I had written, that is edge color none, it simply means that the two colors, whenever they are being separated, they would be separated as though there is no visible line. So I would show you very shortly if I use a different command. So for example, if I open a different figure called as figure 11, and instead of 8, if I use 64, so that's the only thing that I have done differently here. And if I evaluate this and put it side by side with my other figure, so you can see the difference between the figure on the left and the figure on the right. So in the figure on the left, we had used 64 different shades of colors, and on the right we had used 8 different shades of color. So sometimes it is up to us whether we want to show the difference to be very stark, or whether we want to show a very gradual changes, or whether we want to make our contour plots look a little bit more smooth. So this is something that you can adjust. And finally, you can also use something called as edge color. So here I have used, instead of none, I have used K. So K in MATLAB usually indicates a black color. So if I run this particular line, you can see that in the previous case, which had no color, the colors were separated freely without any visibly distinct lines. But on the right hand side, these black lines are separating the different colors. So these are all the different ways in which the contour plots can be manipulated. But my recommendation is, whenever you create a plot, always ensure that you put your labels on that. So for example, if I want to just go back to my original figure, which is my figure 1. So on the x-axis, if you look, then there are numbers from 0 to 5, which means that we are talking about the x vector. And on the y-axis, we have number from 0 to 1, which is my y vector. So there are commands called as x label and y label. And again, in the small brackets, we are writing something in the double inverted commas. So these are simply called as strings. If you remember, these are simply characters. So everything that we want to use for the label is nothing but a character. So this is how we can label the plots, and it is always a very good practice to label the plots. In case of contour plot, you might also want to say what this contour is of, and for that you can use the title command. So title command would give you title of, so for example, this particular case, we were using z as x square plus y square. So if I hit this particular line, this title would come up on the top. So this is something that is always a good practice when even when you are doing line plots. It is good that you tell the viewer as to what that line represents, whether that line is corresponds to, let's say, Reynolds number of 500, whether it's for, I mean, if there are three different lines, we should be able to distinguish what those three different lines recommend or what those three different lines represent just by looking at the plot. You don't have to tell them, okay, this line is for property A, this line is for property B. They should be ingrained in your plot, just like how we had ingrained this z equals to x square plus y square. So with this, people would be able to tell that, okay, this is my x, this is my y, and this color representation that I'm seeing, or this distribution that I'm seeing, corresponds to a field that is given by x square plus y square. So I hope that by the end of this video, you might have learned at least one new thing that you didn't know before, or you might have just brushed up all your concepts and would be more comfortable in the programming language. In case if there are any more burning questions, please feel free to write it down in the comments. I would try my best to reach out to you as soon as I can. In any case, I hope I see you next time. Until then, take care and bye-bye.